Let's do some very quick review of chapter 1. Okay, so LCM. In order to find LCM, what do? We take the lowest power. For example, if you prime factorize and you get 2 cube 2 square into 5 cube into 7 to the power, let's say 5, and then you prime factorize another number and you're getting 2 5 into 5 3 into let's say 11 square, suppose, then LCM will be the highest power of 2, which means in this case there's 2 to the power 2 and there's 2 to the power 5, so it will simply be 2 to the power 5, the highest power of 5, that is 5 cube, and then since there's no 7 here, the highest power of 7 is 7 to the power 5, and then 11 to the power 2. So this will be the LCM. So it does not matter if it's numbers or alphabets. Even if it's alphabet, you will get the same, you will do the same. So if it's A, B, C also, you will be doing the same highest power thingy. Okay, so you don't have to write 2 again and 5 again, you just write the highest power ones. And as for HCF, if we are supposed to do HCF for the same thing, then we take the lowest power. So for HCF, the lowest power is 2 square in this case. The lowest power among 5 cube and 5 cube is 5 cube only. And then among 7 to the power 5, and see, if there's a 7 to the power 5 here, there's no 7 to the power 5 here, but we can imagine that there's a 7 to the power 0, because 7 to the power 0 is 1 only. We can literally put anything number to the power 0 and then it will be 1. The value will be equal to 1. So we can write here 11 to the power 0 also. So among this, the lowest is this 0 0. So we don't have to count this because it will count it as 1 only. But literally you can do this also, but this into 0 is 1, this into 0 is 1. So the lowest power is this. So the HCF will be this, LCM will be this, the highest powers. So even if I put 7 to the power, the highest power is still 7 to the power 5. So I'm going to write 7 to the power 5 here. Great. So that's how you take LCM, highest powers, HCF, lowest powers. And then do remember the relationship of HCF and LCM, which is LCM into HCF equal to LCM of A and B into HCF of A and B will be equal to A into B. Next thing is, look at the textbook, trying to see anything of this form to the power n will always end in 0. Other than this form, any other form will not end in 0. So it doesn't matter if there's other numbers along with this. It can be 7 into 3 into 2 into 5. It'll still end in 0 because there's a 5 into 2. 5 into 2 means 10. You already know that. So 10 power, it'll always end in 0. But other than there should be a 2 and 5 as well. It cannot be just 7 into 3 into 2. Or it cannot be 7 into 3 into 5. It has to, it needs 2 and 5 together to end something in 0. Okay. Next is for showing that numbers are composite numbers, you just have to take common. 5 into 7 into 11 plus 7 into 13, suppose. So you just take 7 common. This makes it into a composite number. That's it, nothing else. So that's the one. And from exercise 1.4 we have the highest power. So in order for a number to be terminating in the denominator, it should have either 2 to the power something, or in the denominator, here you can be anything. Okay, anything at all. It can be 5 to the power something, or it should be 2 to the power something into 5 to the power something. Here it doesn't matter what it is. So as long as it's this, this, or this, it will be terminating. And then if there is any other number attached to this, this, or this, it will not be terminating. Any number attached. For example, 3 into this is not terminating. 2 into this will be terminating because 2 and 5. But if I write 7 into this, non-terminating. Got it? But if I write this 2n into 10, this is terminating because 10 is literally 2 into 5. So you have to understand that concept also. So any prime numbers attached to this, will be non-terminating in a very clear way. Okay, so if it's only this or this, then it will be terminating. And then after how many decimals will it be terminating? After the highest power of 2 or 5. So for example, if it was on the denominator, if there's like 2 to the power 7, then it will terminate after 7 places. Even if there is 5 to the power 5 attached to it, it will still terminate after 7 places because this is the highest power. Got it? That's it. And irrational numbers are non-terminating and non-repeating. Okay, non-terminating, non-repeating is irrational. So it should not terminate and it should not repeat also. For example, 1.010010001, all the stuff. And pi is also an irrational number, and e is also an irrational number. What else is there? Irrational numbers. Root over any prime number is irrational number, and so on. So that marks our chapter 1 review. I think that's about it. And remember, before you do solve this one, the prime factorization thingy, you always have to see if you can cut something or not. Right? You always have to see. Just because there's a 3 here doesn't mean it's going to be non-terminating. You have to see if you can cut or not. Then only you have to do. Next, chapter number 2. For chapter number 2, 2.1 is about zeros. Okay. For 2.1, first thing first, the line where this intersects, the line. So suppose it's intersecting at 1, 2, 3, minus 1, minus 2. The zeros of this equation will be minus 2 and 3. So if I were to ask you to make an equation or take out an equation using just by looking at the line, you will first see what the zeros are. One is 3, one is minus 2, wherever it's touching the x-axis, and you're just going to do x squared minus x into sum plus product, which you already know the formula. So x squared minus, if you add these two, you will get 1 because minus 2 plus 3 is 1. So 1x, and if you multiply these two, you will get 6. 3 to the 6 minus 6 minus 6. So this is an equation that passes through these two as the zeros. One more thing, if suppose if I ask you, okay, next thing you also have to remember is that this equation, okay, this equation which we just met that passes through this and this equation is an equation, and when you solve for x values, when you put like when x equal to 1 enough, to if you want to know a coordinate, okay, then y-axis is given by this equation, the whole equation. So it's like when x equal to 1, y equal to 1 square minus 1 minus 6. So y equal to 1 minus 1 is 0, so minus 6. So x la jaga de 1 de takinamde, y do minus 6 below. So the diagram should be something like this actually. Got it or not? Minus 6 should be here. It should be something like this. So this diagram, if I were to draw it properly again, 1, 2, 3, minus 1, minus 2, and then minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So minus 6 is on the side, so it will be actually something like this, the diagram passing through minus 1 minus 6, because when x is 1, y we're getting minus 6. Similarly, you can put 2, you can put 3. So it's like when you put 2, this is the x coordinate, this is the y coordinate. So this line, this parabola will pass through this coordinate. That's what it literally means. So when you put x equal to 2, suppose, then you will get 2 square minus 2 minus 6, so 2 square is 4. 4 minus 2 minus 8, so minus 4. So when x is 2, y is minus 4. So it will pass through this point. Got it? x2, y minus 4. See? It's coming out now. Ini murah factor robustly. Ini olay jaya x2 minus 4. So it will always pass through these points. Okay? You have to remember that also. So which means like if we want, okay, so the figure will be somewhat like this. The actual figure will be somewhat like this. Okay, so if we want to know the y-intercept means where the equation is, like y-axis equal to y as well. Nah? This is our x, this is our y. So in case we want to know where the parabola is touching the y-axis, all you have to do is, because on y-axis x is 0, so you just put y equal to 0 minus 6. Instead of the x 0, instead of the x 0, and this is constant, just leave it as it is. So y equal to minus 6. So at minus 6, the parabola is touching the y-axis. That's how you find the y-intercept, in case you want to know. And one more question, one more thing from this exercise. Suppose if I say to make an equation, I don't think this kind of question might come now. Okay, if I say to make an equation like the zeros to be 1 and 2, suppose, now, and then I ask you to make an equation which passes the y-axis, which makes an y-axis intercept at, let's say, minus 2. Let's just say, so it should, or minus 4, it should pass through minus 4, and it should have the zeros as this, which means x-intercept, it should pass through the x-axis. It's called x-intercept, right? So x-axis there, it one pass 1 and 2, and it should pass minus 4 in the y-axis. So what we're going to do is, we're going to do the same formula, minus sum of zeros, which means 3, product of zeros, which means 2. But now I want it to pass minus 4, right? So what I'm gonna do is, see, equal to 0 na? I'm gonna multiply this, both this and this, in such a way that the constant term, this is called the constant term na? Without the x, the constant term becomes this. So we can do that, multiplying both sides by minus 2. That way we'll get minus 2x squared plus 6x minus 4 equal to 0. Now this equation will pass through y-axis at minus 4, and if I prime factorize this, okay, I will get the same 1 and 2 as the zeros. Why? Because, let me tell you why. If I take everything that side, 0 equal to 2x squared, or literally I can take minus 2 common from here, x squared minus 3x plus 2 equal to 0, then send minus 2 this side, it will become 0. And if I prime factorize this again, I will get 1 and 2 as the zeros, because 1 and 2 were connected. Got it or not? And even if you prime factorize this, the whole this, after making it positive, x squared or positive like a number, even if you prime factorize this, you will still get 1 and 2. Let me show you. 4 2s are 8, so 8, 6. 2 4s are 4 plus 2. So 2x squared minus 2x minus 4x plus 4. So 2x I can take common, x minus 2. 4 I can take common, x minus 1. X minus 1 equals 0. So x minus 1, 2x minus 4, x equal to 1, or x equal to 4 by 2, which is 2. So we will get 1 and 2 only. So it doesn't actually matter what you multiply and what you don't. So if you want an equation with this as zeros and passing through the y-intercept at minus 4, then this is the equation, this. because when you want to find y, when you want to find the y-intercept, you put x there 0, so that 0 0 and last time minus 4 for y. And the diagram will be something like 1 and 2. So it'll come something like this: 1 2, and it passes to the y, it touches the y at minus 4. Excuse me. Anyway, that's it for exercise 2.1. all the Because I know that you guys are very confused over that diagram thing on periodic case for condition, and you know how to find the zeros. I've explained here only. Split the middle term is there, one of the process, and then sum of the zeros, product of the zeros. So sum of the zeros will be given by minus b by a. Product of zeros will be given by c by a. Yes. And oh yes, whenever they give suppose 2x squared plus 5x plus 7 is there, and then they want us to find, if alpha and beta are the zeros of this, they want us to find the zeros of, let's say, alpha by beta and beta by alpha. So first we find the sum. So we literally do the same thing, okay? X squared minus x into sum, which means plus product, so alpha beta into beta alpha. So we just cancel this, so it will become 1. So x squared minus x into x squared alpha squared plus beta squared by alpha beta. And the formula for a squared plus b squared is a plus b the whole square minus 2ab by alpha beta plus 1. So what is alpha beta? So alpha beta is the product of zeros, which means c by a. In this case, c is 7, a is 2, and then sum of zeros, which means alpha plus beta equal to minus b by a, so minus 5 by a is 2. So all you have to do is just put minus 5 by 2 the whole square here. So minus 5 by 2 the whole square means 5 is 25 by 4 minus 2 into 7 by 2 by 7 by 2. You take the LCM and whatnot, and then you get the answer. This is just a random number that I gave, okay, off the top of my head. But in exam, if this kind of question comes, it won't come this kind of a complicated question. Don't worry about that, because it's just going to be MCQ. So it might be like 1 by alpha plus 1 by beta. That's an easy question, that because it'll just be alpha beta. So itu formula cila ulangan ina nai wo mah complicated to nai. Simple lai wo equation. Budiya na. So that's one of the thing. And suppose x squared plus 7x plus a, or ax squared plus 7x plus let's say a plus 3. Okay, this is an equation, suppose, and they're saying one of the zeros is 1. You're supposed to find the value of a. So if they're saying it's zeros, it means you have to put it into 0, and instead of x you just put 1 and go. 7 into 1 plus a plus 3 equal to 0. So a into 1 is a, so a plus a is 2a. 7 plus 3 is 10, so minus 10, so a is minus 5, like such. Got it? So if there's an unknown value and you're supposed to find an unknown value, and they give you a value of the zeros, you just put equal to 0, and then instead of x you put the unknown value, you'll get the answer. So that's it for chapter 1. For chapter 3, first thing first, you have to know that suppose it's a1x1 plus b1y plus c equal to 0, a2x plus b2y plus c2 equal to 0. So these equations represent the line, okay? And line means there's 3 options. One is it's gonna be parallel, one is they're gonna intersect each other, and one is they're gonna coincide. Coincide means on top of each other. So literally it's the same line. Yes. So without drawing a graph, you can know the lines by doing a1 by a2, finding it out, and then b1 by b2. If it's not equal, then it's intersecting. If it's equal but not equal to this one, then it's parallel. And if everything is equal to each other, I'm quite sure you all know this, but we're just revising, then it will be coincident. Yes. And then in case you want to know how to draw a graph from a line, suppose 2x plus y equal to 5. So what you're supposed to do is you're going to separate x completely or y completely. It doesn't matter which one. So in this case, let's just separate y. And then you're going to start doing when x equal to 0, y equal to, it doesn't matter what you put, okay? Just put small values. Don't put big values. So 5 minus 2 into 0 is 0 equal to 5. When x is 1, y equal to 5 minus 2 into 1 equal to 2 into 1 is 2. So 5 minus 2 is 3. So we have 2 points now. So all you have to do is draw the from the graph, x is 0, y is 5. So x is 0, y is 5, should be somewhere around here. And then x is 1, y is 3. So let's say it's somewhere around here. 1, 3. This is 0, 5. And you just join these two and you get the line. So that's the line of this equation. So it's very simple. It's simple as that. Okay. I suppose that's, there's nothing much to it about the graph from chapter 3 other than that. So in case you see a line and they're asking you which of it is the equation. Suppose itu nujane. Moi tu line digina doange. Nah, and then I ask you which equation does this, what is the equation of the line, and I give you options. So in one of the options is this, in other options I give 3x minus y equal to 3, okay, just random, 5x plus 2y equal to 0, kind of a thing, okay, any random equations. All you have to do is see that the lines satisfy both the equations. For example, if I give 3x plus y equal to 5. Okay, suppose these are the 4 equations: option A, option B, option C, option D. And I ask you this line, which equation does it belong to? Suppose. So first you're going to put 0 in place of x and see if you're getting y or not. So if you put 0 instead of x, anything with 0 is 0, so minus y is 3. But we need 5 as the answer. So this is rejected. If I put 0 here, so 5 into 0 plus 2y equal to 0. So this will become 0, so y will get 0, which is not 5. But in these two, it will satisfy the equation. Why? Because, see, if I put instead of x 0, 3 into 0 plus y equal to 5, anything with 0, 0, so y equal to 5, we're getting y equal to 5. But in this equation also, it will satisfy it, because 2 into 0 is 0 plus y equal to 5 and y equal to 5 we're getting. So it's not like only one equation will satisfy a point, okay? Because in a point, we can literally draw infinite number of points. But the equation should satisfy both the points. Got it? So if it's passing through 0, 5 and it's passing through 1, 3, now if you put instead of x 1, you have to get y as 3. So by chance for x 1 2 into 3 into 1 plus y equal to 5. So 3 into 1 is 3. If I take it that side, it will become 5 minus 3, which is 2. And we need 3 as the equation, y value, when we are putting 1 as x, but we are getting 2. So that will not be the solution. So instead, if I put instead of x 1, see what we get. 2 into 1 plus y equal to 5, y equal to 5 minus 2, which is 3, which is exactly this. So this will be the equation. Got it? So that's it with graph thingy. 3.3, you use elimination method only, doesn't matter. I know it's a substitution method question, but just use elimination. Whenever you're doing fractions, you're going to put x, y, and then you're going to add or subtract according to what they're asking, equal to the fraction. Okay, when you're doing age questions, if you're talking about past, always take the past age for both. If it's like 5 years past, then you have to subtract x minus 5 and y minus 5 and then put the condition according to whatever they're asking. If it's about future, like 3 years in future, you have to put x plus 3, y plus 3 and then put the equation, double the age, triple the age, whatever. Got it? For fixed charge, the fixed charge will be there and then whatever into the per charge, per day charge, per kilometer charge, whatever, and then this will be the total money. I don't have time to go through all the word problems, so I'm just going to skip it. Suppose they give an equation 2x plus 3y equals 7, suppose, let's just say, and then kx minus 3y equal to 18, whatever, and then they're saying if this has no solution, then if it's no solution, 2yk is equal to 3y minus 3 is not equal to 17 by 18. So this you don't even need it, so you just forget about that, and then you're going to do only with this. So k is equal to minus 2. So only when k is minus 2, then it will have no solution. But if it's equal to, then if it's infinitely number of solutions, then you do equal to this one also, and then you can compare this or compare this. But if it's infinity solution, remember this, even if you take these two, you will get the same answer as taking these two or whatever it is. Okay, the equation itself will be like that only. The equation itself will be in such a way that even if you take these two or these two or these two, you will get the same answers only. And then for yeah, that's it. Unique solution, they will never give this kind of questions. Find the k and all. It's either going to be infinitely many solutions or no solution. And yeah, and for this thing, long questions, for example, the both of stream upwards and downwards one, for example. So you don't have to write anything or this thing direct. You have to make the like equation directly. Okay, don't waste time making this thing. So you know that it's going to be distance divided by speed, the time. Now, so you just write 13 kilometers upstream, so x minus y, plus 15 kilometers downstream, x plus y. It takes 5 hours, so 5 hours, and equation 1, and then direct really. And for example, questions like, yeah, and I think we're out of time. From chapter 3 to chapter 6. From chapter 6, okay, I'll just go really fast. For chapter 6, one is Thales theorem. Thales theorem is this by this equal to this by this. So A, B, C, D, E, then AD by DB equal to AE by EC. But it's not just this, okay, Thales theorem. You can even do AD by AB equal to AE by AC. And even you can do BD by AB equal to EC by AC also. It doesn't matter. All are Thales theorem, okay? But as long as if you're taking this, then you have to take this shorter one. That's the only condition. Otherwise, everything is possible for Thales theorem. And Thales theorem is also called basic proportionality theorem, BPT. Basic proportionality theorem, okay? And the next one would be similar triangles. Whenever you see similar triangles, suppose suppose this angle and this angle is equal, and obviously these two triangles, the A, B, C, D, E, ABC will be similar to DEC. Why? Because this angle and this angle is the same, and angle C and angle C is also same. So when you're drawing the similar triangles, you always remember to draw one of the triangle first, any one of the triangle, and while you're drawing the other triangle, you have to draw in such a way that the same angles are together. So in this case, C and C is together, so you write C here, and then B and E is together, so you write E here and then D here. It's not like sometimes it might be even like this, nah, without any question. Suppose this, suppose mulai deh makin awas. Okay. Let me look at another question. Suppose we have a triangle like this. Suppose this is 90 degree, this is 90 degree, and this A, B, C, this D and E. Suppose these two, this is a triangle. There are two triangles attached here, right? So they are similar because they're sharing angle C. So while you're writing ABC, you're going to write one of the triangles first, and for the other triangle, you're going to draw exactly the same way you drew ABC. And then angle B is 90 degree in this case. So first you're going to see what angle is equal to this. So in this triangle, the 90 degree is D. So you're going to write D here. And then the common angle that's sharing both is C. So C is here. So you have to write C first. And then what is left? E is left. So you write E. That's how you do. And then you take the proportions. And if these two triangles are similar, you know that AC by EC will always be equal to AB by ED will always be equal to CB by CD. Okay. And then the next 6.3 or 4, I don't know, is area of ABC. Suppose there's like ABC triangle, ABC, and it's exactly proportional to DEF. Suppose exactly, okay, like this angle is same, this angle and this angle is same, kind of a thing. Then we can say that triangle area of ABC and area of DEF will be equal to AB by DE, AB square by DE square, or you could even say AC by DF. And remember, we can take square common also, so you can literally write it like this also, or you can write BC square by EF square. So it's the same thing, taking the common and squaring. And then the last one is Pythagoras theorem. So everyone knows about Pythagoras theorem, the last exercise. Anyway, that's it. Good luck for your